Good evening, class. This video is going to cover Microsoft Office Access 2013 Unit K, working with data. The objectives in this unit will be how to open an existing database, how to sort records in a table, how to filter records in a table, create a query, modify a query in Design View. We're going to learn how to relate two tables, create a query using two tables, and add a calculated field to a table. Okay, so to open an existing database is very similar to how you would open any file in Microsoft Word, Excel, or PowerPoint. You can do it one of two ways. You can navigate to the file directly and double click the file and it will open in Access, or you can open Access first and browse to the file from within Access, and you can open the file that way as well. Now there is one caveat between opening an Access database and opening a file in Word or Excel, and that is you can only open one Access database file at a time, and that's within an instance of Access or a session of Access. To open multiple databases, you will need to open additional sessions of Access and then open the database. So it can be done, but you have to open a second session of Access to open a second database. Okay, sorting records in a table. Sorting is basically rearranging the records in a table in alphabetical or numerical order. There are a couple of ways you can sort records. You can sort them in ascending order, which would be A to Z, or for the numerics it would be 0 to 9. And descending order, which would be from Z to A, alphabetical, and from 9 to 0 for a numeric sort. And there's also, excuse me, you might also want to sort records using more than one field, which that's possible. We'll talk about that on the next slide. Whoops. Okay, looks like it's two slides over. Okay, excuse me. Threw me off there for a second. Before we get to how to sort on multiple fields, we're going to talk about how to capture a screenshot of a sorted table. To do that, you can open another application like Microsoft Word, PowerPoint, or even Excel if you would like. Click the Insert tab and find the Screenshot button, and once you click the Screenshot button, you'll see a image of available windows for to capture the screenshot. Select the window that includes the sorted table, and it'll paste it into a new Word document which can be saved. You can do that again with Microsoft PowerPoint. You could also do it in Excel if needed, and then you can click the program excuse me, the Access Program button on the taskbar to return back to Access. Okay, now we're on moving on to sorting on multiple fields. When you sort on multiple fields, you need to decide which one will be the primary sort field, which will be and which field is to be sorted within the primary field grouping. So the field that is the primary is called the outermost sort field, and the field that is the secondary sort field is called the innermost sort field. And to get the results you want, you must first sort the records by the innermost sort field and then sort by the outermost sort field. So here's an example. We're going to click over to our database. We're going to open up our houses table, and we're going to sort, let's see, in this case we're going to sort by state. So we're going to sort A to Z, and this will be our innermost sort. And you can see we've sorted in alphabetical order, starting with D, moving all the way down through, looks like S is the letter of the last state. And then I want to also sort by last name. So my innermost sort is state, since we performed that sort first, and I want to also sort on the last name in alphabetical order. So you can see that my primary sort is the last name field because it is in an alphabetical order all the way down, and then the secondary sort is on the state field. As you can see, it is in alphabetical order based on the last name sort. So those are going to be our innermost and outermost sort. That's how that's performed when sorting on multiple fields. Alright, so filtering records. Filtering records is some people get excuse me, some people get filtering and sorting records kind of confused. They're similar but not the same. Sorting just reorders the records, as we're filtering only shows or displays records based on a certain set of criteria, and that's the set of criteria that you set. And you can see the second bullet point, definition of criteria is basically just conditions that must be met for a record to be displayed. And the simplest way to filter a table is to select a field that matches your criterion and use the equals command to display those records that match that selection. So we'll give an example. In this case, we want to, let's just say we want to view all the records of houses that are found in the city of Slapout. So we will go to text filters, we will select equals, we'll type in the city name Slapout, click OK. Alright, and you can see that now we've filtered down to the 3 records in the table that have Slapout as the city. Alright, so that's how you perform a equals filter, or a filter based on equals with a criteria that you specify. And to clear my filter, you can do it one of 2 ways. You can select the clear filter from city option, or you can just simply click select all, and either one will return the table back to its original format. Will remove the filters. There are also a few other ways that you can filter. I can simply in the text box below, or the dialog box below, I can remove the select all check mark, and I can scroll down and find the city that I want to filter on. In this case it would be Slapout, and you can see we get the same 3 records. Or if I want to look at everything but Slapout, I can check the select all box, uncheck the Slapout box, click OK, and then you'll see that all of my cities are present with the exception of Slapout. Okay, so that's how you perform filtering. Let's see, now you can also apply a number filter to a selected column or field, and then you can filter records that are greater than, less than, or equal to a specific number, or between 2 different numbers. Filters cannot be saved as database objects, but you can create a query that returns the desired set of results, and we'll get to that in just a minute. Filters can be saved as part of a table or form you're working on and reapplied it the next time, but they can't be saved outright, and not as a database object. And filter results can also be printed. Okay, so let's move on to queries. How to create a query. A query is a database object that extracts data from one or more tables in a database according to criteria that you set. And a query displays only the fields you specify, so they don't necessarily have to display the entire table. You can pull out 3 or 4 fields, just the ones that you're most interested in, or as you see necessary. And a query is an object, so you can save it for later use. And the simplest way to create a query is by using the query wizard, which we'll do. This slide gives a couple of details of select field buttons in a query wizard, which we'll demonstrate in just a second. Essentially, the single arrows move an object to the left or right one by one. The double arrows move all available objects, from the selected box to the available box, and vice versa. And we'll demonstrate that in just a minute. Let's see. Modifying a query in Design View. You can modify an existing query if you need to make changes using Design View, just like you can modify a table in Design View that we touched on in the last lecture. And in Design View you can add fields, delete fields, you can specify sort order for one or more fields, you can specify criteria for fields, and you can create a query. So let's give an example here, or working example. Alright, let's say that I want to, I'm going to clear my filter from my houses table. Let's say I want to create a query using the query wizard right here, and as I mentioned in the last lecture, Excel requires you to save your objects on a regular basis, so it just prompted me to save there, which I did. Alright, so here's our query wizard. New query. For the purposes of this class, we're going to always create simple queries using the simple query wizard. So the default selection here is OK. Now it's asking me which table, which fields do I want my query in from which table. So in this case, we have the table houses is selected already for us because that's the table that was selected in our navigation pane. And in this case, I really only want the address, the city, the state. Let's see. Whoops, let's move that back. So I want the address, I want the city, I want the state. Don't really care about the zip code, first, last name. And I want the number of baths, and I want the number of bedrooms. Okay. Now you notice that I moved my selected fields from the available fields boxes in a couple of different ways. You can double click. You can move them one at a time using these arrows from left to right. If I selected one too many, let's say I selected the zip code by mistake, I can move it back using that arrow. Or I can move the entire selected field box, all the fields in that box back using my double left arrow. Okay. Alright, so we've got our field selected. We're going next. Would I like a detail or summary query? I would like a detail query, so I want to see the details. It gives you an explanation. It says that shows every field of every record, which is what we want. And then the next, the title from our query will be houses query, and then that's all the information the wizard needs to create your query. Do you want to open the query or modify the query's design? For this demonstration, we're going to go ahead and open the query to view the information. We're going to click finish, and there's our query. You can see it's the same information in the house containing that houses table, but it only displays the 5 fields selected. Okay, so that's great, but what if I want to know, what if I need to drill down even further? Well, if we need to drill down even further in a query that we've already created, we can simply go to, let's double click our houses query. This is what we're looking at. Go to the home tab, and remember we can modify in design view. Alright, so this is what our design view looks like for our houses query, and you can see at the top of the screen we're using the houses query. That's where we are. We're selected the houses query over here. So these are the 5 fields that we selected. Now let's say that we want to look for houses that have at least 2 baths and at least 3 bedrooms. Now what does that criteria says? For baths, we want records. We want all houses to display that have greater than or equal to 2 baths. So that means 2 or more baths. That's how you would read that. And for the bedrooms, we want houses that have at least 3 bedrooms, so that would also be greater than or equal to 3 bedrooms. So now that we've added this criteria to our query, top left hand corner, we'll select the run button to rerun our query, and now we have an even smaller set of data. So we've got 17 records, and you'll notice that all the baths are at least 2 bathrooms, and the bedrooms are at least 3 bedrooms or more. So it's basically 3 to 5 bedrooms and 2 to 3 bathrooms, and there are a couple that have a half bath. So that's how a query would work. Okay, so we just demonstrated how to create a query and how to modify a query. Let's say I wanted to refine my query even further and just say I wanted houses that only had 3 bedrooms, but they needed to have at least 2 baths. We'll run again, and now you can see all our bedrooms, all the records listed have 3 bedrooms and at least 2 baths. So that's how you create a query, and that's also how you modify a query. Let's flip back over to our presentation. Relating to tables, you can take advantage of the power of access. You may want to create queries that pull fields from more than one table. Queries can be used to relate to tables or specify a relationship between them. To relate tables, they must share a common field. The shared field must be the primary key field in one of those tables. Okay, so we touched on primary key back in Unit J. That's a unique identifier, and it must be shared in those two tables that you're going to relate. Doesn't have to be the primary key in each table, but that field has to reside in each table. Okay, you must use the relationships window to specify a relationship between two or more tables. And the most common type of relationship to set up is a one-to-many relationship in which the primary key field in one table is associated with multiple records in a second table. In the second table, the common field shared with the first table is called the foreign key. Okay, so this is getting a little bit into database theory, which you won't have to know much for the exam. But you will need to understand how to relate tables. So let's talk a little bit about relationships. The most common type of relationship is a one-to-many relationship. Well, what is a one-to-many relationship? Okay, a good example of what a one-to-many relationship would be is if we had, let's just say we had a couple of database tables. One was titled instructors and had all the instructors at Shelton's information in it, and one had students, which had all the student information in it. Okay, then they would have classes, so forth and so on. Well, a one-to-many relationship, a good example of that would be for every class there's one instructor, but there are many students. Okay, so what that means is a one-to-many relationship is there can be one for every student in this class that we're in, CIS 146. There are roughly like 30 students in this course. So each one of you, your instructor for this course is me. Okay, so there's only one instructor, but from my perspective, I have many students. So there's roughly 30 students in this section of this course. So that would be an example of a one-to-many relationship. Okay, there are other relationships that do exist in database theory, but we're not going to get into those. There is a one-to-one relationship. There's a many-to-many relationship. One-to-many is the most common, and that's the one we're going to use here. So that's the one we're going to stick with. Now, that last bullet point, the second table, the common field shared with the first table is called the foreign key. So let's see if I have an example of that here. Let's look at our tables. Let's look at realtors. Let's see. Realtor ID and houses. Yes. Okay, so for this example, we'll take a look. Let's see. Realty company ID. Looks like realtors are going to be our best example here. So for this example, our realtors table has the primary key set as the realtor ID. Okay, so that's the primary key in the realtors table. If I wanted to run a query based on the realtors and houses tables, I can do that because the houses table also has the realtor ID. Now you'll notice it's not the primary key, but it is included in the table, so we can link these two tables together, and I can pull data from both tables into one query. Alright, so in that case, let's see, database tools, relationships. Alright, so in this case, looks like I've already got some relationships that are existing, and you can see in the lines between the two tables. These are our tables. These boxes represent a table. This is our realty company table. This is our realtors table. This is our houses table. So the relationship we want to focus on is the realtors and houses relationship. And you can see the realtor is the primary key in the realtors table, and the realtor ID also resides or is also found in the houses table. So this is the same data. Realtor ID, realtor ID. So But from a table perspective, in the realtors table, there are no reoccurring realtor IDs. So let's take a look at our realtor ID just so you can see. So realtor ID, you can see that there are no duplicates because that is the primary key. You have Fred Smith, his ID is FS, this is his initials. Mr. Haney is just H. Imogene Hogg, her realtor ID is IH, that's her initials. Mary Jones, MJ, SJ for Sue Jones, TJ for Tom Jones. Alright, now if we look at our houses table, we can see that our realtor ID, some of these repeat. IH repeats several times. There's MJ a few times, SJ, H several times, FS. So you can see that in the houses table, the realtor ID repeats multiple times, but it's not the primary key, so it can do that. Alright, so back to our database tools and our relationships. So in this case, we have a one-to-many relationship. We have, for every one realtor ID, we can have many houses. Okay, that's how this reads. So we have one-to-many. The infinity symbol here indicates many. So for every one realtor, they can have multiple houses listed. Okay, so we've got our relationship already set up. And just for reference, if you had to actually set up your relationship, you would go to the database tools tab, you would select your tables, and you would find the fields, and to link the two together you would click and drag across and it would create a relationship. Now in this case, since the relationship already exists, there's no need to create a new one, so I'm going to say no, but that's how you would create a relationship. And you can also edit it if you need to. And you would do so by double clicking that line and it'll allow you to edit. Okay. Alright, so let's flip back over. Relating to tables. We did that just now. And understanding good database design. Before we get to that, let's give an example of creating a query across two tables. So we're going to use the query wizard. We're going to create a simple query like we did last time. We're going to use realtors. We're going to use the realtor ID, their first and last name. And we're also going to use houses, and we're going to select the address, city, and state. Okay, so now we're including data from two different tables. We're going to click next. We want a detailed query. Yes, we do. We're going to call this our realtors query, and then in this case we're just going to look at the raw query results. So we're going to select leave open the query to view information selected and click finish. Alright, so now what we've done is we've created a query that's pulling data from the realtor table and data from the houses table, and they're related by this realtor ID field. So that's what a query that uses a relationship looks like. It pulls data from two separate tables into one query. And this is really the power of databases. You can create tables within your database and have them related, by one field per table. And you can create queries that will pull information from multiple tables into one query, so you can view it as needed. And you can specify which field based on what criteria. Okay. And if I wanted to edit this query, it's just like we did before. We would click the view, the design view, and let's just say I wanted to look at realtor, only one realtor with the criteria of FS. I would type that criteria in. That's the initials, I believe, for Fred Smith. Click run, and now the query only displays the realtor ID FS. Okay, and I can always go back and remove that and put my query back to normal, just like so. Okay, so that is relating two tables and creating a query based off of those two tables. All right, understanding good database design. We have just a few slides left here. This is crucial. This is critically important when you create your own database. Won't do very much of this in this course, but if you do this later on in your college career, you'll understand what I mean. creating a well-designed database requires careful planning. We know some of the questions you would ask yourself is, what's the purpose? What data will it store? Organize the database into categories of data. Turn the categories of data into tables. Define fields, data types, primary keys. You want to create a well-designed structure for your database, and that will ensure your data is easy to access, maintain, and update. So let's just take a look at the tables, for example. So this is a real estate database, and it includes houses, which we would expect, realtors, which we would expect, realty companies, maybe, and a friends table. Okay, so friends, we may question why that table is in there, but it is for this exercise. But one good way, whoops, I want to make another point. But you can see, so we've got the houses table, and all this information that we have, we would expect to see, or we would need to know about a house. It has an address, it's located in a city, it's located in a state, and a zip code. There's an owner who has a first and last name, they have a phone number, and then there's a list price. We would always want to know the number of bedrooms and bathrooms. The list date, sometimes it's important, and the realtor ID will help us find out who, or determine who we need to contact to get information about the house. So those are what I would call attributes. And the reason why I call them attributes, if you think about when you create a database, a database has a purpose. In this case, our example is real estate. Okay, so within that database, we have different objects that we need to define and gather information on the attributes of that object. So, for example, we have realtors. That's an object. And we have first name, last name, phone numbers, realtor ID. Houses, that could be considered an object. It has address, city, state, zip, list price, bedrooms, bathroom. All those are attributes of that house. So if you'll notice, in the houses table, all this information is attributes of that house. Okay, for a realtor, let's look at the real. These are attributes of that realtor. The realtor has an ID, he has a first name, last name, or she has an email address, home phone, work phone, mobile phone, and they have a real estate company. Okay, so those are attributes of this object, this realtor table object. Okay, that's how this needs to be viewed. If you were a good example is if you were a veterinarian and you wanted to create a database on the animals that you treat, you could have a table for dogs, and you could have, male, female, the type of dog, whether it's a German Shepherd, a Cocker Spaniel, a Boxer. You could have age, weight, height, last visit, a notes field for any notes that you would have that you would want to keep on that dog. If you were treating cats, you could have something similar, or you could create a table that's just specifically animals and then have the type of animal it is. So you need to think of tables as the attributes of whatever the object that table represents, whether it's a dog, cat, realtor, home, or houses in our case. That's kind of how your thought process needs to work. Alright, so creating a query using tables, we've already touched on this, but we'll cover this slide. So we set up the relationship between tables. It offers many advantages. It creates the ability to create a query that pulls fields from two or more related tables, which we demonstrated. And changes made to fields in one table are automatically reflected in related tables or queries if referential integrity is selected. So let's flip back over to our relationships. So on our database tools tab, we'll click the relationships button. So we're going to double click our line since this is our relationship, and you can see this talks about our relationship. So when we create our relationship, we will have some options here. So in this case, we related the realtor ID in the realtors table with the realtor ID in the houses table, and you can notice that the enforce referential integrity checkbox is selected. It's checked. That means right here that it ensures consistent and accurate data. That's why we enforce referential integrity. So if we have two tables that are linked together, and let's just say we have a query that is designed not to only pull data but maybe update data. Well, if we update the data in one place, we want to make sure it gets updated everywhere that's relevant. Okay, let's say we change Fred Smith's realtor ID from FS to FT. Well, we would need that to change everywhere. So that's why referential integrity is important and should be selected, because if we change data that's relevant in one place, it needs to be changed everywhere it's relevant, and that's what that means. Okay, just a little more information on creating a query using two tables. Once you set up the table relationships, that also ensures that your data is valid and accurate, which is very critical in database management. And Access will prohibit any attempt to enter data in the foreign key field that is not consistent with the data in the primary key field. So you can't, what that's saying is that you cannot change the primary key or the foreign key that's linked with another table if that data is not consistent with the data in the primary key field. It's not going to let you change it because that's your unique identifier. Remember, that's critical data and it can't be changed. Okay, not without updating it elsewhere. All right, so let's see. Table K2. This is in your textbook. These are just some operators that we talked about a little bit earlier. These are mathematical operators that can be used in queries. You saw me demonstrating when we were created the query on the houses table. We were using the greater than, and actually we use the greater than and equal to operator for bedrooms and bathrooms. But you can use the greater than, less than, equals, and then the not equal to if there's a situation where you want to return records that are everything but one particular criteria. Let's just say we wanted to look at all the houses except the ones that had two bathrooms, then we could use the not equal to operator, and that would help us weed out those records that we don't want to see. And and lastly, on our last slide, adding a calculated field to a table. A calculated field is a field that contains an expression, which is a combination of fields, values, and mathematical operators. Showing the results of calculations based on values in certain fields is very useful. And calculated fields have the calculated data type, so it has its own data type. And choosing a calculated data type opens the expression builder dialog box, where you can easily build the expression you want to specify by fields, values, and operators. So that's similar to where you would create your formula, the expression builder. And you have used similar operators that we saw in Excel. But what you're really doing is you're creating a calculation or writing an expression that's based on data listed in the tables. So it's similar. It references the information in the table, just like we had cell references in Excel. And anytime that data is updated, well, your formula or your calculated field will automatically update too. So, but you'll see some examples of that in your tutorial, and you'll be able to work with it there. So that's going to do it for Unit J. If you have any questions, let me know via course messages, and we'll talk to you soon.